go too long. I will apologize up front. I've done a lot of academic experience here, so I tend to talk too much. All right? You mean you want me to walk around like this? All right. Sharif asked me to do a presentation on artificial intelligence. I've taught AI for probably 12 years now, and I tried to take, I think, something like 57 slide decks and pile that down into one deck that I can go through in 30 minutes. So, happy to talk about the subject, trying to keep this at a level that will hopefully shed some light on different aspects of it, and I guess we'll go from there. To start off, just a quick thank you to everybody that was crazy enough to put this together and invite me to show up and talk about the topic. As I mentioned, I have spent a lot of time in the tech industry. I've spent a fair amount of time teaching tech, and over the last 12 years, a lot of that has become artificial intelligence and various aspects of that. I will tell you today that my goal is not to talk about a cloud or any of that kind of good stuff. My goal is to talk to you about what I consider to be fundamentals of artificial intelligence. So, to start with, I usually like to do this with my students where I kind of punt back and say, let's talk the real basic stuff. What do I mean when we say artificial intelligence? Okay? Because I've met some people that if we're trying to model that after, it's probably not going to come out with a good outcome. Okay? So what we're looking to be able to do is use some of the technologies we have to further our cognitive skills, our abilities to reason, our abilities to learn, our abilities to solve problems. Okay? And I stuck a slide all the way in the back. I've rearranged this deck I don't know how many times at this point. Wikipedia has a lovely definition of cognition, and one of the key pieces of it is the use of knowledge to learn knowledge, which is kind of how we get to where we are at this point in our lives. So, in terms of looking at artificial intelligence, one of the things we expect people to do is take data, information. They're going to make some sort of decisions around that data. Is it good? Is it bad? And then they're going to use that data in some way, shape, or form to make decisions or carry out actions. What we're looking for AI to do is be able to supplement that. And if I look at this basic model of AI is really the data, it's the analytics, and it's the action on those analytics. And each one of those three pieces is very important. Today we talk about data. It used to be data was only structured. It came from my ERP system, or it came from something that looked like a spreadsheet. Today data comes in so many forms and fashions and shapes. We've got streaming data, we've got graphical data, we've got movie data, we've still got the traditional data too. But we need to be able to take all that in and somehow make sense of it. I absolutely love Netflix and their recommendation engine. And I always usually tend to ask students, you know, you've all been somehow categorized by Netflix. Okay, Netflix says you like drama, or you like romance, or you like adventure. So when I go into Netflix and it wants to tell me what's trending, it gives me all these little pictures of the current movies that are out. Because it's got me tagged as somebody that likes an adventure movie, do I see the same little piece that they would show somebody that wants to see a romance movie? So when I think about how I can take this data and start shaping it, there's all kinds of information I can get out of that, and that leads me into this concept of analytics. And the analytics piece of this is incredibly important. And we'll get to a slide on that in a minute. But the analytics and the data together inform what we want to be able to do from an automation standpoint. I want to make a decision. I want it to be a good decision. Okay? It's not going to be a perfect decision. But sometimes I need the decision quickly. The value of information decays over time. How do I shorten that time? So if I have somebody calling in and they have a problem and I want to be able to address it as quickly as possible, putting something together like an agent and leveraging artificial intelligence is a great way to do that. I can get them to an answer quicker. Whereas if they call during the week or after hours or on the weekend, they're going to get a different level of response. So in looking at this, this is sort of what I'm looking to drive AI to do. When I say AI, we all tend to think about, oh, it's machine learning or it's natural language processing. Artificial intelligence is plugged into so many things today that we don't even stop and think about it. The capability of your phone to unlock on your face is leveraging AI. How it boils your face down and how it recognizes it depending upon how you're looking. Or try to spoof your phone sometime. Make goofy faces. See if it'll unlock for you. Okay. That's a great one in class, by the way. Usually they all disappear and they sit in the back of the room making faces at their phones. The key, though, here is it's in a lot of different areas. Vision, speech, planning, robotics. And you're going to see it in even more. Okay? We're seeing it show up now in terms of coding, co-pilots, all kinds of good stuff like that. At some point, there's lots of companies out there that are looking to have AI, generate AI, which gets into a whole other discussion about whether we will understand the algorithms that they come up with. In general, I can talk about AI in terms of narrow AI, general AI, and we'll call it superintelligent. Everybody wants to talk about when it's going to be here and it's going to do everything, okay? I would not worry about that too much at present, but I would point out there's some lovely things out here, and when I put the slide deck out, there's a lot of links in here. One of my favorites, I use this with every class, there's a movie out there called AlphaGo. If you're not familiar with a company called Deep Think out of London, they wanted to build a game to play Go. And they built something called AlphaGo. The movie is about 90 minutes long. I find it well worth watching. And they built this and they played Lee Sedol, who was one of the world champions at Go. Spoiler alert, the AI beat him 4-1. Okay? But at the end of the movie, you're rooting for the people. You really are. The interesting thing, and the reason I like to use this, is because when they were done, they came back and they created a new version called Alpha Zero. Okay? Alpha Zero was built in a very different way. And what Alpha Zero did was basically learn to play Go by itself. When Alpha Zero was done, it beat AlphaGo 100 games to nothing. Okay? So that does get into some interesting concepts here in terms of, does our understanding of the model or does our interpretation of the data limit what AI is going to do when we try to apply it? So there's going to be some really interesting things that sort of evolve out of this, but one of the key pieces here is the model is what makes the difference. AlphaGo was built by a bunch of people that played really good Go, telling it what a good move was. Alpha Zero was built by telling it the rules of the game and getting out of the way. Okay, two versions of AlphaGo played each other. I think the magic number was somewhere around 40 days. And at the end of the 40 days, they figured it wasn't going to get much better, but it really didn't matter because probably in about 20 days it could beat anybody that wanted to play Go with it. When I look at what goes into AI, it is a combination of the algorithms and the data. You can have the best algorithms in the world, and if you feed it crummy data, remember the old saying, garbage in, garbage out? It will still apply, okay? When I talk about the role of the algorithms, they fall into three categories: supervised learning, unsupervised learning, and reinforcement learning. AlphaGo was built with supervised learning. This is a good move, this is a bad move. Alpha Zero was built more with reinforcement learning than anything else, but it was pretty much unsupervised. They just let it play itself and derive what were good moves. By the way, the Alpha Zero version now plays chess and any kind of net zero game along that line. And in applying it to chess, they've discovered new moves that grand chess masters have not seen before. So it gives you an idea of the insight that this can provide. So we have the algorithms, we also have data. And the data is important from the aspect of both training and testing the model. Okay, if I'm going to build a model to simulate, pick a sales pipeline or something of that nature so I can look at some parameters, it's very important how I put that data in, and the data set that I use I want to divide into two pieces so that I have a training piece and I have a testing piece. So as I adjust the algorithms, I can keep repeating through this and come back and say, okay, I'm making good choices here, or I'm altering things in a positive way. The data is critical. The quality of the data and the relevance of the data. It is very easy to take a narrow data set and end up with a skewed view of something, okay? Making sure the data is good enough in terms of clean, normalized, doing anything you might have to do with feature engineering, which leads to whole new discussions around things like synthetic data. Have you guys heard the term synthetic data? No? Have you heard the term data poisoning? If you haven't heard the term data poisoning, you will probably see a lot of companies coming back trying to put stuff in their data so that if somebody else pulls it up with an AI by chance, they can make sure they don't get the right answer out of it. So this is going to open up all kinds of crazy new things. The process of training this, we need to initialize a model. We go through a process called forward propagation to run the data through it. We basically do back propagation to figure out what kind of error we're getting, and then we optimize it, okay? That's as deep as I'll go there. Oh. Let me see. How algorithms shape your world, 15-minute YouTube. The guy does it's a TED Talk. He does an incredible job. It's well worth listening, and he has some interesting insights there. When I talk about the algorithms, because they're a key piece of this, you can see I can break this down into different categories. There are algorithms for unsupervised learning. There are algorithms for supervised learning. And there are algorithms for reinforcement learning. So depending upon what I want to do, if I'm a bank and I'm interested in doing fraud detection, I'm probably playing with algorithms that fall in the classification category. Okay? If I'm trying to do something like, I don't know, feature elicitation, I'm probably doing dimensional reduction. If I look at what Netflix does to try to boil you down and all those different factors I'm trying to track with you, I'm probably using algorithms like that. And if I take this and look at it at a more academic stance, there's lots of algorithms out here, okay? And I will confess, I recognize about 4 of them, and I probably remember how to use maybe 3 of them at this stage in life, okay? So these are things that, if you don't know, you can always find it. That's what Google and ChatGPT and all that good stuff are for now. But if you look at this, you can see these algorithms are sort of broken out into deep learning. They're regularization, regression, clustering, all the different kinds of things that you would look at an AI and say, you know, what am I trying to do? What am I trying to do with the data? How do I want to leverage this and take it somewhere? So if I think about the data is what's going to basically identify patterns to the model. So that I'm going to start with a model, and I'm going to start running data through it because I want it to see things that I possibly may not. If you worked for Netflix, I'm sure you probably started out with some basics in terms of how do we recommend movies to people. All right? They have well exceeded the capability of doing that at this point, and they're leveraging these sort of tools on the back end to consume the variety of data. When I go out to Netflix and they're suggesting movies, you know, this is what's trending, this is what's new, how long I hover over that is telling them something. And they now do it so it's all little video clips. So if you stay there for 2 seconds or 3 seconds, they're determining how much interest you have in these different things. And all that becomes a feature that they are using as part of their model to come back and drive. The training and testing piece of this is incredibly important because I need to be able to take data and run this through and say, based on what I know, this is good, okay? And I need to be able to test that in a way that they came from the same data set. If I were to go out here and put together some sort of mortgage approval program or application like that, there's lots of them out there now. There's a whole bunch of factors. If you applied for a mortgage 35 years ago, they probably were concerned with how long have you been employed. Like if you jumped jobs a lot, they didn't want to loan you money for some reason. They didn't figure you were a good risk. Today, that's not an important factor. Okay, most people change jobs far more frequently. We'll talk about that a little bit more, but that's the key factor. So when I build my model, is my model staying stagnant, once I get it there, this is the particular way I want to drive this going forward? Or do I expect this to learn and adapt? And do I trust it to adapt by itself, or do I need a mechanism for measuring how did it change? The training data, usually if I'm going to do something in this nature, I need lots of data. Depending upon your organization, they've been collecting data for years. As long as it's relatively complete, you can do some really good stuff with it. Many organizations have data that's been migrated over the years and enriched. So the data that I have from the last 5 years is a little richer than what I have from 10 years ago, or a lot richer than what I had 20 years ago. I take this data, I train my model, and then I come back and validate it. Usually the data comes out of the same test set. All right, we split it so that I can make sure I don't have some sort of anomalies in here where I got one set of data in one place and one in another. It fits together in a very nice way. And then I need to be careful of doing things like overfitting. All right? I really want this to be accurate, but what I'm really looking for in an algorithm like this is for it to be generalized. Okay? If you remember, I don't know about you guys, when they taught me the multiplication table, they stopped at 12 times 12. Okay, if you ask me anything in that range, there's a number. It just shows up in my head automatically. If you ask me 14 times anything, I look stupid. There's a reason for that. Okay? They thought I had generalized the algorithm at that point and knew how to apply it. That's what we're looking for when we do AI. And the last thing you want to do is overfit or underfit. Okay? There's a link down here in terms of selecting a machine learning model, and they start out with a real basic. We all remember y equals mx plus b, and we're trying to get this so I can project a value. And if they just gave me the points, how do I figure out what the line was? What was the equation? And if it's not linear, and we get into second or third or fourth order polynomials, somebody mathematically could probably take every data point and make sure the line and the equation fit. Which is not a good thing then, because when I want it to be generalized, if I bring my test data over, every point is off the line. So what I'm looking for is coming up with a balance. I need it to be detailed enough that the information I'm going to get out is useful. I need it to be general enough that it's not going to show things up as anomalies. Usually, everybody wants to talk about machine learning and deep learning. And if I look at artificial intelligence, just like I said, there's a lot of different branches that you could run through in terms of AI and its application. If I think of artificial intelligence, machine learning is a domain within that. And within the machine learning domain is another one called deep learning. And when I get into deep learning, this is where I really get into sophisticated neural networks. You'll hear things like convolutional neural networks, recurrent neural networks, generative adversarial networks. There's all kinds of different networks that can be built leveraging the neural capabilities. This is the only geek slide I'll spend a minute on, but if we talk about the process of building a neural network, what I'm trying to do is take a collection of inputs, your data, and I'm trying to run it through a process whereby it's going to have some patterns, there's going to be some algorithms that apply to it, and I'm going to get some value out of this at the end. That's my goal. I want a happy endpoint. And if I'm a bank or somebody, a credit card company, and I've got 30 years and tons of data and data patterns, I can leverage something this in a really great way. I can come back and say, what represents fraudulent card usage? And they have the numbers, so they can see the patterns, and they can come back and they can run their model and they can get a prediction, and then they can compare it to the actual value and say, I'm 85% accurate. You can then go through a process called backward propagation where I optimize this model, and what that's going to do is adjust weights and a collection of other things that are in here. But the end game is I'm going to run the same data through it again. And when I get another set of answers, I'm going to compare them. I'm going to say, is this better or is this worse? And this is where the computational power of AI comes in, because now I can turn this loose and say, I've got a model, and every one of those little circles is a node in the model, and every one of those has a weight, and every one of those things has feeding into it. What happens if I tweak this one by that much, or this one by this much? How many different permutations are there when I go through this? This is what really consumes CPU and resources. The goal of this, though, is that when I'm done, I've gone through a process where I know I've adjusted and tweaked this till I have minimized my error rate. And what I have coming out the other end is as accurate and as close to the real-world data that I put into it. Okay? Again, this is an example of supervised learning. These are some of the examples of different neural network types that are out there. And again, they all serve specific purposes. So somewhere out here you will see deep fast forward. You will see, I think we have recurrent neural networks out here. There's Markov chains. And obviously you can see I've spent time with computer science people as well as folks that get off in like, I understand as many of these, I don't want to say as the algorithms in terms of regression and things like that. But the end game is, if I look at some of these, how they're constructed and how they function. A generative adversarial network. How many of you have been to a website called thispersondoesnotexist.com? Every time you hit reload, it generates a new face, and you would swear every single one of them is a real person. Okay? The model was built by consuming tons and tons of real photographs, breaking it down. What does a face look like? Eyes, nose, all those different features. When it's done, it has the ability to generate an image. In a generative adversarial network, there's really two networks in this. One is generating images, and this one is trying to determine if that image passes the test, so to speak. So anytime you go out to, and there's a collection of the sites out there right now, anytime you go out here and look at a generative adversarial application, they've already got AI looking at the output to come back and say, I think this is good enough. Okay. So if I take a column of 50 numbers and put it in my spreadsheet, I don't care how big they are, we're all pretty comfortable that they add up when we got to the bottom, right? We don't question any of that. When I look at some of these things, and the AI can produce something that's better than I can look at and tell, does that make it good? Or does that just maybe mean it's playing off, it's smarter than me. It can beat me at Go. Okay? So as you think about that, there's a couple things you need to consider. When you build these models, the data patterns change. It's referred to as data drift. All right? The patterns that you see today that they may have built and trained these models on may not be the same tomorrow or next week. There's all kinds of external things that change the way people behave, and the people are generating the data. Those are the events that are happening out there. We also have model drift, where people build models, and all of a sudden, maybe this isn't as important, and there's some things that basically change over time there. And then the last one of these, because every organization that's out here now is playing in this arena, I think if you go out and check, Gartner now has an entire sequence on what they call XOps, which is basically DevOps for AI. How do I manage it? How do I track it? How do I lock down a model and say this is our current production model, these are the versions of it we're experimenting with? How do I take it back to a point in time? Has the data made it drift? Do I need to come back and reset it? So there's a collection of different things that come into play in this, and unfortunately, that's all I could fit in 30 minutes. Questions? So the question is, where do I see the fundamentals? And I think right now, for a large part of the AI that is out there, we still have, I want to say, the human guardrails on it. So when I look at Google and some of these other folks, and they're going to come back and say, we're going to let AI generate AI, I'm not sure if we will understand. We've already seen Google set up some things where it developed its own language to communicate with itself. Okay? But for a large degree, depending upon how these are being applied, right now from a business perspective, we're using agents, we're using a lot of things. This is still very much narrow AI. Okay, we have not really gotten to a generalized AI where I can dump all my business data in and kind of play with it like Notebook LM and just ask questions of it, and it's going to come back and say, yeah, I think you should go look at this or something of that nature. But I would anticipate it is going to continue to evolve. I told you there's, very narrow, there's general, and then there's this concept. And if you talk to people like, it's the singularity is coming, okay? Everybody will argue with you, is that going to be here in 2 years? Is that going to be here in 5 years? Is it going to get here at all? I guess that's going to depend upon who controls the AI and those aspects of it. Which goes back to, everybody knows about ChatGPT and OpenAI. Is there a closed AI that we don't know about? Other questions? Sharif, I didn't put you to sleep, did I? I'm an accidental professor.
Yeah, Tim is actually a professor at Villanova University and the president of Agile Cloud Consulting. So, you have to be pretty smart to be a professor for your side job.
And I post bail. There's no other questions? Okay. Thank you. If you pull the deck up, I left a whole bunch of reference material in here so you can go out and poke and play. If you want to find some data sets to go out here and play with AI, there's lots of fun stuff out here. How to decide on a model to start with. Dolly Lives is fascinating. Go watch it. You can have Dolly actually show up in the museum and talk to you. You can take a selfie with it. Crazy experiments. I have tons and tons of this stuff. As I said, I probably have 50-some slide decks. So you got the 30-minute distillation. I hope it was useful. Thank you.